In part one of this series of working with PsychoPy, we learned that there's two main ways you could build experiments. You can code them from scratch using the PsychoPy coder view, or there's the PsychoPy builder view, where there's a visual interface for constructing your experiments. Now in this video, I want to focus in on the coder view and talk about the underlying Python code you can write to build experiments. And this is something I recommend everybody have a baseline experience with. Even if you plan on primarily constructing your experiments in the builder, you will occasionally find yourself wanting to work with the code. For example, if we look at the components they make available, you'll see under custom, there is a code element you can add to your experiments. And this is helpful because sometimes there are things that are just more efficient to do via code, or sometimes you're just trying to do something more advanced that you can't do with the builder interface alone, and being able to write some custom code and interject that into your experiment could be really useful. So now that we understand our motivation for learning about the code, let's jump into our example. I've got a simple experiment set up that we can run through. If you want to follow along and get the code for this experiment, you can go to the notes that accompany this video. You'll find this under version 1 code. There's 2 versions. In the second version, we evolved it a little bit, add some more features, but we're going to start off really simple. So like I said, if you want to follow along, you can go ahead and copy this code, and then in the PsychoPy coder view, you can create a new file using the new file icon on the top left. And then once you've got that file created, you could paste in the code, and then you could go to File, Save As, and save this file somewhere on your computer. In my case, I saved it as LDT, or lexical decision task for short, and it does have a .py extension, short for Python, because that is the underlying coding language we're working with when we're building these experiments in PsychoPy. So with our code file set up, let's just start by running the experiment so we can see what it does. So I'm going to click the little green play button. Here's our experiment window. You can see we start with a set of instructions for the participant. They're told that they're about to see a series of characters. If the characters make up a word, press the right arrow key, otherwise press the left arrow key, and then we'll press space to begin the experiment. So I'll go ahead and do that. All right, so here's our first series of characters, T, that is a word, so I'll press the right arrow key. Jewel is not a word, so I'm going to press the left arrow key, and I'll just continue with this pattern until eventually the experiment ends, at which point the window just closes and we're returned to the coder view, which is a bit abrupt. And you'll see in version 2 of this code, we'll expand on this so we have like an end screen that thanks the participant for completing the experiment and gives them the option to actually close it. But we wanted a very basic example to begin with, so we haven't added that yet. All right, now the other thing to observe at the end of the experiment, if we look at the output, I'm just going to scroll up past these warnings. There are several warnings talking about your monitor's frame rate. This has to do with the fact that when we're doing experiments, oftentimes we want to be very precise about timing. We want to be measuring the participant's reaction time, and a lot of that is influenced by the frame rate of the monitor in which the participant is using. So those things can be calibrated with PsychoPy. A little bit beyond the scope of what we want to be talking about in this video. So I'm just going to skim up past that. And what I want to get to is just the output that is produced by this experiment. We ended up with a CSV list of values. And then for each row, we see the series of characters that were presented, and then a 1 or 0 following that. The first 1 or 0 represents whether or not it was actually a word. So in the case of T, that is a word. So we see 1, which is just representative of true. And then following that, we see another 1. This is indicating whether or not the participant got it correct. So if we look down for all of the words, we could see 1 straight down the line, which means when I just ran this experiment, I got it correct for all of them. All right, so again, very rudimentary example here where we're just outputting the CSV data. We will expand on this so we can record the data in an external file so you could do analyses on your experiment results as needed. But this is just a very basic proof of concept. All right, so reverse engineering things, that's the end goal. That's what this experiment does. Let's zoom in and see how it does this. Starting at the very top of the file where we import some external modules. And this is very typical when you're working with Python. You have the code that you're going to be writing, but you're often importing external tools that you're going to be using in your code. In this example, the most important modules we're pulling in is from the PsychoPy Python library itself. So we see from PsychoPy import, and there's 3 modules we're pulling in: core, visual, and event. Core is going to give us access to some baseline functionality for our experiments. Visual is going to give us access to things like creating the experiment window, customizing that window. And then event is going to give us access to things like creating key listeners. That's how we're going to listen for the left and right arrow key, the space bar, all of that stuff we get from the event module. Now for each of these modules, I want to draw your attention to the documentation. So coming back to the notes that accompany this video, you'll see I have links to the PsychoPy documentation for core, visual, and event. And if you follow those links, you're just going to see information about what those modules provide, all of the methods within that modules, what are the parameters those modules are expecting. So this is going to be something you're going to be cross-referencing as you're working with PsychoPy code. All right, so after pulling in the things we need from PsychoPy, we're also importing this random module that is going to allow us to randomize our word conditions. And this is just a general Python module. It's not PsychoPy specific. Moving past our imports, I create a variable called results, and I set it to be an empty string. This is a variable we're going to build upon as we go through the experiment, and we're going to add our results through each trial of the experiment. So think of this almost as like a blank sheet of paper at the beginning of the experiment, and then we'll add on to that as we go through. Following that, I've hard-coded our conditions. So I created a Python list. In Python, we create lists with these square brackets. And within this list, I have a series of sublists where each sublist contains one of our words or pseudo words, followed by a Boolean value of true or false, or we're representing that as 1 or 0 here as to whether those characters are a word. So cat, t, bar, those are all words, so they get 1s, and ool, jewel, and pock are not words, so they all get 0s. All right, now we always start off with a small subset of conditions when building experiments, because you're going to find that as you're writing the code, you're going to be running your experiment and testing it. And if you had, say, 100 conditions, it would be very tedious every time you had to run it and test it to have to go through 100 conditions. So always start with a very small subset. And then once the experiment is working how you want, you could always expand on this later, pulling in more conditions. In fact, in version 2 of this, rather than hard coding the conditions, I'm going to show you how we could have an external data file with our conditions where we could have hundreds of conditions there, and we could actually import them to our experiment. All right, now after we define the conditions, we are using that random module. And within that random module is a method called shuffle, and we're going to shuffle our conditions. And this is just going to make it so that our conditions are presented in a random order each time we run this experiment. Moving on line 17 is where we are going to initialize the actual PsychoPy experiment window. We're doing that with the visual module, which we imported from the PsychoPy library. And within that module is a method called window. And there's many parameters we can pass this method that are going to customize our window. The 2 parameters I'm passing it are the size and the color. For size, I'm setting this to be 800 by 700. And for color, I'm setting it to be black. Now let's cross-reference this with the documentation just to start to get familiar with the documentation and see all the other parameter options we have when it comes to creating our window. So going back to the browser, looking again at the notes that accompany this video, I'm just going to follow the link to the visual.window documentation. And at the top, you'll see all of the various parameters we could use when defining this window. And you'll also see what the default values for those parameters are. For example, here's that size parameter. Now I set it to be 800 by 700. If I hadn't indicated size at all, we would get a default window size of 800 by 600. Alternatively, let's say I didn't want to restrict the window size. I wanted it to actually be full screen. Well, there's actually a parameter for that, full screen, and you can see the default value is none. So by default, full screen is turned off. If we wanted to turn it on, looking down here at the list of parameters, we can see some more details about the parameters. We can see that full screen can take a Boolean value. So that's going to be either true or false. If we had set that to true, when our window popped up, it would take up the entire screen. And that's typically what you want to do when the experiment's done, you're ready to actually share it with participants. You do want a full screen window. That way they can focus on the experiment. They're not seeing any other windows that are currently running on the computer. But at this stage where we're just developing the experiment, I recommend leaving full screen off or none and setting a window size, because as we saw when we ran the experiment, it made it so it's in its own little window that we can move around and see our code at the same time. And that's often useful to kind of run through your experiments while also cross-checking the code behind the scenes. And then, like I said, when you're ready to share it with participants, you could switch to full screen. Now, a little bit of a tangent, since I've got this experiment running again, I do want to talk about how to terminate the experiment window early, which is something that could be useful when you're developing because you're often making little code changes and then running the experiment just to test it quickly. And you don't want to necessarily have to go through the entire experiment each time. Even with a limited set of conditions, that can be a little tedious. So let me show you how to terminate the experiment at any point. If you're on a Mac, you could run the keyboard shortcut Command Q, and that would close the window. On Windows, you can just press the Escape key, and that should close the window. Alternatively, if we go back to the PsychoPy program, I'm just going to go ahead and expand this window. We can see that we've got 3 different views. We're currently in the coder view, but if we click the right view, it's going to bring up the PsychoPy runner, which has details about any experiments that are currently running, and there's a little stop button we could click. That would be another way, in addition to those keyboard shortcuts, to quit the experiment. All right, so that aside, just to recap what we've learned, we've got the window method. It takes various parameters for defining the experiment window itself. And we know for any of those parameters, we can cross-reference them in the documentation to understand what they do, what their default values are, and what we can set them to. All right, now once we've got our window open, typically the first thing we want to do is present some sort of welcome instructions for the user. So what I've done is I created a variable called welcome, and I set it to a string with my welcome introduction text. Now I'm using a Python multi-line string here. The way we define that is we start with 3 single quotes, and then I could use multiple lines to define my instructions, and then I terminate it or end it with 3 single quotes. Now, all that is doing is just defining the text. To actually create a text element that we're going to see in our window, we're going to go back to that visual module that PsychoPy provides, and now we're going to reach for a method called text_stim, that's short for stimulus. And then once again, it's going to take a series of parameters. The first parameter is the PsychoPy window in which this text is going to be displayed. So here we're referencing a variable called window, which we defined up on line 17. This variable captures the result of when we invoked this visual.window method. The other parameters we're setting, we're indicating the color of our text. We're setting it to be white. The text itself, we're setting to be our welcome variable, which we defined above. And then the last 2 parameters are going to indicate our font size. So we're saying we want to use pixels as our units, and then the height is going to be 20. So it'll be 20 pixels high. And once again, let's cross-reference with the documentation. So going back to our notes, I've got a link to the visual.text_stim method. And the thing I want to highlight here, if we look at the first parameter for the window that it's expecting, notice that it doesn't have a default value. It doesn't say window equals something. Because this is a required parameter. Any of these other parameters that have a default value, you can omit them and it'll just go to that default value. But in the case of window, it needs to know what window this text stim is going to be attached to. So you have to include that when creating your text stim. And that makes sense. Obviously, if we're creating this text element, we have to have some window that we're going to be displaying it on. All right, so once again, take a moment to skim through the parameters that are available, but we're just going to continue with our basic example. We've initialized our text stim, and now we're going to get down to the details of how do we actually make it display. And this is a 2-step process. First, we're going to reference our instructions, which we just defined on line 33, and on them, we're going to invoke a method called draw. And then following that, we're going to reference our window variable, which again, we defined up here on line 17. And on that, we're going to invoke a method called flip. Now, to understand these 2 methods, I want you to imagine that you are the experimenter and you're sitting with a participant. Imagine you had a small whiteboard in your hand and you're writing the details of the experiment. And then for the participant to see it, you actually have to flip that whiteboard around to show it to them. That's kind of how PsychoPy works. We have this window and we draw our stimulus on the window, but then for the participant to actually see it, we have to flip that window. And this draw flip process is something you're going to see anytime we're changing the contents of our window or our whiteboard, if that metaphor is helpful. All right, now at the end of our instructions, we told the user to press the spacebar to begin. And the way we're going to listen for that action is we're going to reference the event module. This is one of those modules we pulled in from the PsychoPy library. And within there is a method called wait keys, where we can listen for keyboard responses. We're going to pass this a parameter called keylist, where we're going to indicate which keys we're going to be listening for. And in this case, we're just listening for the spacebar, which is just represented by this string called space. So the effect of this line is it's actually going to pause our program at this point, and it's going to wait for the participant to press the spacebar before continuing on with the rest of the code, which is where the words are actually displayed. And that makes sense. We want the user to be able to read through the instructions, and when they're ready to begin the experiment, then they press space, at which point the rest of the code would execute. All right, now just like we did with text, stim, and window, I do want to draw your attention to the documentation for this. So once again, let's go back to the notes. This time we're looking at the event module, and we can see that this module provides functionality for not only listening to key presses, which is what we're currently doing, but you could also listen for mouse clicks. And in fact, that's where it starts. So we see some details about that. We can get things like the position of the mouse click, when it was pressed, etc. Let's scroll down and find the details about the get keys method that we're using. So here it is, event.getKeys. You can see the parameter key list that we passed it. There's a parameter for modifiers. So if we wanted to listen to, say, like the command key and the shift key in addition to some other key, we would allow modifiers. And then finally, if we wanted some time information as for when the keys were actually pressed, we could change timestamped to be true. All right, so that's the basics of get keys. Let's go back to our code and see what happens next. After the user presses the spacebar, we then get to the trials section of our experiment. So this is where we're actually going to display our characters. And the way I've set this up is via a for loop. So we're saying for condition in conditions. And remember, conditions was something we already defined up above. It is a list of all of our words. Or more specifically, I should say characters, because sometimes they are words and sometimes they aren't. But each of our sets of characters are represented by their own individual sublists within here. And the first element in this sublist is going to be the series of characters itself as a string. And then the second element is going to be a Boolean value, 1 or 0, where 1 is true and 0 is false, as to whether or not those characters are a word or not. All right, so understanding that structure here, when we're looping through, each time through this loop of conditions, this variable condition is going to represent a single condition. And you can see from that condition, we're extracting the different parts. So we have condition at 0 and condition at 1. We're setting that to be a variable called characters and also is word, right? Because the first part of the condition is the characters themselves. And the second part of the condition is that Boolean value as to whether or not it's a word. All right, now taking that information from our condition, we then can create another text stim. So we pass it the same window, we indicate the same color. The text that's going to be in the stimulus is now going to be our characters. So that comes from this line here. And then once again, we can set the pixel height or the font size of that word. Then we say word.draw, and then we have to remember to flip our window so the participant actually sees it. And then once they see it, we're going to do another event.waitKeys, but this time in our key list, rather than waiting for just the spacebar, we're going to listen for either the right or the left arrow, and that's just represented by the string right or left. Now in this example with our wait keys, notice that we are collecting the response of the wait keys in this variable called response, because we need to know which of the keys they press to indicate whether or not they got it correct. Now this is a little bit different if we go back up to our wait keys for the spacebar. We didn't actually set that to a variable because we didn't care what key was pressed. We just knew that the spacebar was pressed, at which point we would continue with the rest of the experiment. But here we need to know if it's right or left. So we collect that in this response variable, and then we use that in this if, else branch, where we're going to try to record a Boolean value for correct of either true or false. Now, the two conditions in which they got it correct would be if the word itself is a word, so is word is true, and their response was the right key. Or the other condition in which correct would be true is if it's not a word and their response was the left key. Otherwise, the third and final condition would just be that they didn't get it correct. Now notice here the response variable. I didn't just say response is the right key. I had to say response at 0 because the result we get from wait keys is always going to be a list of values that's going to include any of the keys that were pressed and also potentially timecode information about when they were pressed, assuming that was one of the parameters we requested. And just to highlight that, let me take a moment. I'm just going to add a debugging print statement here. Just have it print out the response itself so we can look at that data structure and understand why accessing the 0th element in that structure was necessary. So let me go ahead and run it with that print statement. All right, so here's our welcome screen. I'm going to press the space bar to begin. And then here's our first condition that we see. It's not a word, so I'm going to press the left arrow key. And if we look at the output, we can see the result of that print statement. So it's printing left, but it's not just the string left. We have the square brackets there indicating this is a Python list. All right, and that's why we need to use response at 0 to actually access that value to drill into that list. All right, so just keep that in mind anytime you're working with wait keys and you're getting the response, you are getting a list back. All right, let me go ahead and terminate that experiment, and I'll get rid of that temporary print statement. And then skimming down, the last thing happening in the for loop is we just want to record our results. And looking at this, this is a previous approach I had used to recording the results, but I've since updated the code. So if you copied the code from my website to follow along, you're seeing something different here. So just give me a moment. I'm just going to update this with what you're probably seeing. All right, it's just basically it's doing the same thing that previous code was doing. It's just a little simpler way of doing it. So this is what I want to focus on. All right, so here's where it's constructing our results. And what it's doing is it's referencing that results variable that we had initialized at the top of this file. Remember, we set it to be an empty string. And what it's doing is each iteration through this loop, it's just adding on to that. So here we're using the plus equal sign to append to whatever results were. And what we're appending is going to be a string of CSV data, comma, separated value data. The idea being is ultimately results, we're just printing it to the output right now, but we could save the results to a CSV file, which we could then import into some data analysis program. All right, now our CSV string looks like this. We're going to start with the characters itself. So this is referencing our characters variable. So it'll be T or bar or ool or whatever the participant saw. Following that, we'll have a comma. Then we're going to record whether or not it was a word, referencing our isWord variable, which we defined up here. Now I am wrapping this in Python string method to convert that 1 or 0 to be a string, because I can't join together an integer with a string using these concatenation characters in Python. I would get an error if I did that. So I just need to make sure everything in this string is a string. It is of the same data type, so it can be glued together, so to speak. Following that, we have another comma, and then we record whether or not the participant got it correct. And once again, we have to translate that 1 or 0 to a string in order for this to work. And then we wrap it up with a \n, which is a special character. It's basically just going to represent a line break in this data. All right, and then after the for loop at the very end, we print our results. And I'll just scroll up through my output. We can see a previous iteration of when we ran this experiment, what those results look like. So this is what we end up with from building up this results variable. So once again, each iteration through our condition or each instance of our trial, we record the characters that were presented, whether or not it was a word, and whether or not the participant got it correct. And you'll notice that even though we converted it to a string, visually it appears the same. It just appears as a 0 or 1, but behind the scenes, the data type that Python sees this as is going to be a string. And like I said, that was necessary to be able to join these strings together. So that's our rudimentary data output, and it does set us up for eventually expanding on this, like I said, saving it to, say, an external CSV file. Now, the last two lines we see in this experiment file is window.close and core.quit. This is going to make it so that the experiment completes and the window closes. And technically, you could omit these, and what would happen is when it gets to the end of the code and it sees there's nothing else to execute, it would close the experiment window. But it's a good idea to include these lines just to make sure that any resources the experiment window is using is actually freed up, that you don't have any ongoing processes that are running. So long story short, best practices, just make sure your experiments always end with these two lines. And with that, that's as far as I'm going to take this experiment in this video, but I am going to have a second part of this video, which I'll link in the description, and we're going to expand on this. We're going to add some more advanced features, which I'll include a quick summary of those features on the screen right now. The other thing to be looking out for is I will also have a video on building this same experiment, this lexical decision task, but using just the PsychoPy builder. So you can compare and contrast the different approaches to making these experiments and hopefully walk away with a holistic understanding of how to use the PsychoPy tools.